This is one question from the chapter relation. The question says that we need to show the relation R and the relation defined on a set A of all polygon. So here domain is, and a codomain is all polygon, right? It's a polygon. And it says that the relation R, P1, P2 says that P1 and P2 have the same number of sides. And we have to show that this is an equivalence relation. First of all, you should know that what is a polygon. You must be knowing that. Closed figure made up of line segment only. Like this is polygon of 3 sides. A quadrilateral is a polygon of 4 sides. And pentagon is a polygon of 5 sides, and so on. Now, we need to first figure out it's an equivalence, find out whether it's an prove, in fact, that we need to prove this as a show that it's a equivalence relation. That means we must prove this reflexive, symmetric, and transitive. Now, in order to prove this as reflexive, I must prove that P1, comma P2 belongs to R for P1 belongs to set A. As you know that if I take a polygon of any number of sides, say for example, I took a polygon of say 7 sides, then the same polygon will have again 7 sides again, right? So we basically say that it is reflexive as the same polygon will have the same number of sides. So it is reflexive. We'll say that it is reflexive. Now for symmetric, what we are going to do is, let's say I took 2 polygons, say P1, P2, that belongs to R, right? Where this R1, sorry, P1 comma P2, I have taken P1, P2 from the set A such that they have the same number of sides, such that P1, that is number of sides of P1, right? P1 and P2 have same number of sides, same number of sides. So if P1 and P2 have the same number of sides, clearly P2 and P1 will also have the same number of sides. So it belongs to R. So hence it is symmetric. For transitive, let's say I took 3 polygon comprising say P1, P2, P3 are their names, right? That belongs to set A such that this is such that P1 and P2 have the same number of sides, right? And P2 and P3 have same number of sides. Assume say it's a hexagon. So if P1, P2 is a hexagon, P2, P3 is hexagon, it implies that P1, comma P3 also belongs to R. It's an hexagon. So you may write further that since P1, P2 have the same number of sides, P2, P3 have the same number of sides, so clearly P1 and P3 also will have the same number of sides. Now, therefore, it says therefore we can say it's a symmetric, reflexive, as well as transitive. So it's an equivalence relation. That should be the statement written. Now, what does its second part says? It says, what is the set of all elements related to A, all right, and related to the right angle triangle with sides 3, 4, 5. So irrespective whether it's an acute angle triangle or right angle triangle, here we are, here the relation is only for the number of sides. And irrespective of the nature of the triangle, we will clearly say that this is a triangle, right? So the element A related is a right angle triangle with sides 3, 4, 5 are those polygon having 3 sides, right? We'll say that related to polygon having 3 sides, and 3 sides polygon is all triangles, right? They are all triangles in a plane. That would be the answer for the next part.